Okay, so for the next one, I'm going to do the other type of mirror, the convex. All right, so all I've done is I've folded under my rules so I can look at the rules at the same time. Okay, so I set this one up again. I have my 3 rules. Like I said, I folded it underneath. I took my paper clip, but this time I held it here with my purple one. Not that it really matters. And then I'm going to draw it here. Okay, so I did that. This is my non-reflecting side. This is the reflecting side. Okay, so this side would look, have those little dashy lines. Okay, so this is for a convex. The rules are the same, all right, but the arrangement of the mirror changes. Okay, so this right here, so as I drew it, this is the center and this is the focal point. Now, this is a virtual focal point because we know the rays of light can't actually get in there. All right, because they're stopped here, they're reflected on the surface and reflect back. So to do convex lenses, remember how I said there was a bunch of different cases? Yes, there are different cases with this one, but they all result in the same thing. So down at the bottom here, I've written malt and just my options. I'm going to go and do my rules again. Now in your textbook, if you want to talk about this, it's on page 426. I'm going to talk about it. If you want to read about it, it's on page 426. All right, so I'm going to choose it to be, let's say 4 lines high. And I don't know if you guys can see these. I just measured out roughly. I know it's beyond the center from the mirror, okay? So we're going to do our rules again. A ray that is parallel to the principal axis gets reflected, okay, to appear to come from the focal point. So here we go. Parallel to the principal axis. Boom. But then you stop because it gets reflected. Well, what direction does it get reflected in? It gets reflected like it's coming from the focal point. So here we go. Remember, it goes in this direction, but our eye thinks it's coming from here. So it comes in parallel, gets reflected to appear to come from the focal point. That's rule number 1. Okay, rule number 2. A ray passing through or appearing to pass through the focal point gets reflected parallel to the principal focus. So that means that when I draw this, I line up the top of my object with the focal point, but do not draw it here. That's just that you know what direction to draw it. You stop, then it gets reflected parallel to the principal axis. And it goes like this, but hang on, your eye doesn't realize and goes, oh, it's actually coming from back there. It's not really, but that's what your eye thinks. So now, this is where our image is. Let's do that last one and see if we did a good job. Now, don't forget, all of these things are on the other side of where the object is. So take my green marker. A ray passing through or appearing to pass through the center of curvature is reflected along the same path. So here's the center of curvature. And you're going to take it from the top. And there we go. So it comes along, it gets reflected back, but our eye thinks it's coming from the center. And they all cross in pretty much the same point. So now you are going to go here and draw in your image. So there's my image. Okay. So now let's talk about, I should have drawn that dotted. Sorry. All right. So now we're done with our 3 rays. I can go over them if you want. Number 1, parallel gets reflected to appear to come from the focal point. Ray 2 it looks like it is going to the focal point. So I actually didn't draw the dotted line there, but if you wanted, you could, but it's a lot of dotted lines. Okay, that's just to know the direction. And it gets reflected parallel. I draw that one back. Okay, And the last one, right through center. Okay? Now, let's examine our image and its characteristics. Okay? All right, so magnification, bigger or smaller? It's smaller, so it's less than 1. Okay, it's a fraction. Attitude, upright. Location, between the mirror and the focal point. And what type? Virtual. Okay, so you should try a couple of these, but I'm telling you right now, they all end up being smaller, upright, between the mirror and the focal point, and virtual. And you've seen these mirrors a lot of places. So in your textbook on page 427, okay, here is a security mirror, and you can see everything is smaller, everything is upright, okay? You would hope that your side mirror, everything is upright. Could you imagine if you were driving and everything was upside down? Okay. Now, would be interesting for you to discuss in class, or maybe with me, or I could post a question. How do the curvatures of these two mirrors compare with each other? And lastly, if you use ATM, which maybe you guys do, you can see a small security mirror there, and that's so you can see people behind you and make sure they're not peering over and stealing your PIN. All right, so you can try those. You should also, if I didn't say, and you should, is read about where these mirrors are useful. If you have a makeup mirror, there's another type of mirror, and what you guys can do is go grab a spoon, take a look at it, okay? Move it back and forth away from your face, and you should be able to see your image get smaller or bigger or upright. So for the spoon facing this way, that would be concave, and you flip it over on the other side, and that will be convex. Maybe you have some really shiny, big serving spoons. It would be easier to see. I'll see if I can find one. Okay, so I went and grabbed a spoon, and I don't know if you guys can see Dumbo. Here's Dumbo. I'm going to put him above the phone. Whoops, got to get my angle right here. Oh, I probably should move my light away. Okay, so here you can see Dumbo. All right. Now I'm on the convex part, and you can see no matter where I move the spoon, Dumbo is always upright. Okay. And he's always smaller. All right, and if I flip it over, Dumbo's smaller, smaller, and as I get closer, he does get bigger. All right, I don't think I can get it big enough there to see him flip over. Okay, that doesn't work, but, you know, oh well, that's the best I can do. Physics in your cutlery.